Hi, in this video I'm going to show an example of how the unique package works in Go. So before I explain what it is about and what it can do, let me show you a simple example first regarding how maps are generally built and accessed in Go. So let's say I have a string map and I'm going to have to do various lookups into that. So let's say I have this string map, which is map of string key and some integer value, and I'm populating its keys with some value. And what are the keys here? Let's just assume in this case the keys are like really long strings, right? And then what I'm doing here is simply measuring the performance, which is basically in the form of the time which it takes to access those keys. So the way string works in Go is that you first basically take its key and then you hash it, and that hash gives you the idea about where the value is actually stored, and then you go to that storage. Okay, so the problem with this is that if you need to hash the same key a lot of times, which this code is doing, okay, so this ops value is what 1 million, but we only have distinct keys of like 500. So in this loop, we only have 500 distinct keys, but we are hashing in total 1 million times. Whereas in reality, we could simply just hash 500 times and access the same values, right? So this is a performance problem for maps in Go. So to tackle this concept of unique package came up, and how this works I'm going to show you. So this is the example which I just showed. In case of a normal map with string key, let's say if you have a very long key, then you have to hash all the n bytes if it is of n byte value, n byte size, and then you get a bucket and you get the value. Whereas what you can do instead is, instead of hashing the key directly, we first establish a correspondence between the key and something called a handle, which is a fixed size pointer to the key. Okay, so instead of basically hashing the entire long key, we could simply take its fixed size pointer and hash that, and uh, then get the corresponding value. Okay, it's basically the same mechanism, but we don't have to hash a really long key all the time. So the way it works is we use something called unique.make, which is a one-time cost to create this something called handle, which is this pointer to this key, and then we only hash that 8 bytes only, because pointers are fixed size 8 bytes, and then we get the bucket and then we get the value. So the point is, we are hashing a smaller key, and at the same time we don't have to hash it all the time. We just have to do it once. So this is what unique package helps us achieve, and I will show you in code how it looks like. So here, so this part was only for the normal string, and now I'm going to show how to do the same thing using the unique package. So here we have something called unique.make, and that interns the string. Okay, and interning is basically means storing only one copy and giving you a small token, which is the handle, which is the pointer to that points to it. Okay, so unique.make interns the string and returns a unique handle, which is a pointer sized token that represents the value. And equal strings always produce the same handle, so you can use it as a cheap map key. So here the first step is to basically create the handles, and we only have to create that many number of handles as we have the number of distinct keys. Okay, so in this case we're making k number of handles, and then in our handle map we are using those handle as the key, just like I mentioned here. Use this as the key and then hash it if you want to access the value. So similar thing we are doing here, and then we are setting the map values. And now we have this performance measurement where we're having this start and end time, and we're simply accessing the same map, and we're simply printing in case of a normal string map, and in case of a handle map we're doing many lookups, and we're simply printing the duration. And I've run this program, and it shows for the normal string map here, it is 27 millisecond for 1 million lookups, whereas in case of the handle map it is just 5 millisecond for 1 million lookups. Okay, so this is a big performance boost in case if you have a program where the performance is really important. So one example here, it can be, let's say you're imagining you imagine processing HTTP access logs where each row has a city. So for example, this path API users, it has San Francisco, and then another call happens for order, and then another call happens, the same one as the first one, which also has the same city. So same key again, and it repeats. So let's say 8,000 rows in total. So 8,000 rows, but let's say total only 200 distinct cities, with each having 256 bytes. So without doing this handle interning, we are having to have this many bytes. But with interning, there is a small overhead, which is the intern table and the handles, but overall it can be significantly cheaper, the amount of total allocation as well as the performance which you just saw. Okay, so this is a very quick example of how to use unique package to gain a performance boost.